in order to be a little bit concrete, I would like to insist a little bit about the complementarity between UIC approach and what is developing within Europe's Religions Undertaking. As you know, UIC is now a member of the system pillar of the ERGU, so we are contributing with all our members. And, well, I would dare to say that we are sharing, I think, the same system vision with ERGU. And I think that's very important that this system vision will be at the heart of everything that we are doing. First of all, I will start with something relatively abstract, which is a network. Can be every network, a telecommunication network, whatever you want. Speaking about railway is basically the backbone. What is the backbone? The backbone is the center of a network. That means that where the interconnection are made with a very high throughput. And that's what we are. When we say we are the backbone of mobility, that's what we should be. We should interface with other modes. So, in a nutshell, what have we to do internally? We have to minimize the internal complexity of the rail system. We have to create interoperable train paths. We have to connect different railway systems. We have to ensure safety and security in the digital age. And that's our homework. But we shall also interface with the other system. We need to create multimodality. That's the outside of the system. We need to interface with other regulation, and we need to create a secured common data exchange, because what the customer wants is to go from A to B, so he will be on the backbone, but he will be also outside the backbone. So we need to create this multimodality. And well, that's quite an old drawing that I made 2 years ago, which is how a data network actually is organized in real life. When you are connecting, I don't know, somebody with mail, or when you are looking to a Netflix program, you are just sending and receiving data between A and B. But for that, you need first to address some kind of virtual level to know, well, what are the servers I have to connect with to have those data delivered. But that is virtual, it's not the actual physical server. Then at the physical layer, when you have more or less identified who are the servers you should address, then you have to do the physical path and where the data should actually be transported. So you see that there is different layers, and all of them, they have a different role. And there is a very clear analogy, and well, that's also a paper that we made basically 2 years ago, to say that, well, we could transpose those layers, well, for those of you that are familiar with telecoms, that a model that is called Open System Interconnection, OSI model. That's a model of the late 70s, actually, for data transmission. And if we take that into our universe, the universe of railway, and if we start at the bottom of the drawing, well, we definitely have a physical layer. So we need to have standards. We need to have the same gauge. We have to have things to the same electrical appliance everywhere. So that's basically what the TSIs are defining. We have what we could call a transport layer that will about the compatibility of the rolling stock with the infrastructure. Well, basically, that's all the interlocking system to be sure that indeed when you select a path, indeed you can do it safely. Then you have a network layer that where the traffic management should occur. And that is something that we need to formalize at the international level and at the European level. Well, you all know what ERTMS means. ERTMS is European Rail Traffic Management System. Well, I think we did what we achieved ERTMS on the transport layer because, well, indeed it works for A to B transport, but the TMS part, the traffic management system part, is still to be done. And what is interesting to see there, and conceptually that's very interesting, that at the network layer, the rail traffic management, there is no basically important safety issues. The safety issues are below. That means that if we want to simplify the system, we can have all the very heavy safety constraint on the transport layer and on the physical layer, but on the layers that are concerned with administrating the traffic, we can have less stringent safety requirements. So that means that we can be simpler, we can be more efficient, and hopefully we can have the connectivity that we want to implement. And the last layer is where we are processing the service, where we are selling the tickets, where we are having the rail freight platform, and so on. Well, the advantage of this architecture is that we are isolating the problem, and that indeed we can be actually efficient. Well, during the process of the system pillar first preliminary discussion, that's a slide that has been presented by the European Commission, and there I will not insist, but you will recognize the same approach in layers. So that means that we are converging in this idea to have layers that will make possible to simplify the whole system. And why are we doing all of that? We are doing all of that to be sure that indeed we can become the backbone of mobility. And this slide, well, I'm training it with you actually today. This one is a brand new one, trying to explain that this notion of backbone is indeed a quite evolutive one. We, as railway, we are certainly the backbone for intercity mobility. Clearly, we are more or less alone with aviation. I should have put a plane on intercity. But as soon as you go into, an urban network, well, there is obviously commuter rail, there are metros, there are trams, there are buses that are indeed also the backbone of mobility. And for the last mile, you have to interface, well, with taxi, with perhaps tomorrow automated vehicles, bike, and so on. So we have to have in mind this architecture, that it is a matricial thing. You can be the backbone for intercity, but at some point you have to interconnect another backbone that will be the backbone for the urban mobility, where you are sharing the burden with other actors. Same thing in the medium density area, where the backbone should be also rail, buses, and for the last mile you have the same actors. And in the low density areas you have, perhaps no more actual trains, but perhaps light trains, more buses and cars. So we have really to integrate the whole system and to have a thinking where we are promoting basically modal shift in using all those possibilities that we have as public transport operators. So in terms of UIC, we are focusing on our added values. We are trying that those added values that are already mentioned, that are about 5G solution for passenger. We have been speaking a lot about OSDM, open share and open sales and distribution model for ticketing, where we will try to make the contribution of this game changer key for implementation of this vision. And I will finish about the fact that we can indeed work together to accelerate the cycle of innovation in being very clear that us, at the railway level, we have to elaborate the requirements. What are the requirements for the system? That's what we are doing in UIC. We are developing the requirements, and we have to articulate with the other standardization bodies that are more on the question of detailed design and product development. So I think that we have a unique opportunity nowadays to deliver fast and to deliver this vision, because first we are working together, and I think at least for Europe, ERGU has been a wonderful place, a wonderful forum where we can work together for delivering this vision. At the UIC level, we will be in and we will help, and we will also try also to gather the other region about this kind of vision. So to make my conclusion, almost 15 minutes, to say that I do think that we can be optimistic, because we have a political momentum, we have technical solutions to be delivered, and we can be on time to demonstrate to our political leader and to our fellow citizens that rail is part of the solution. Thank you for your attention.
Thank you very much indeed, François.